Let's look at a few bivariate cases in the next three slides, which would help us visualize what's going on. So this example is taken from Ang and Tang's book. We have the joint PMF of two discrete random variables, x and y. So as you can see, there are 5 possible values of x and 5 possible values of y. And if you plot these on the plane with x and y being the two axes and the third dimension being the probability mass, then this is what it looks like. So the height is proportional to the probability, and we can clearly see that few of these points in the grid have no probability mass, they are 0. For example, x1 and y4 has no probability mass, and the highest mass is at 2, 2, which is 0.36. Now we could obtain the marginal mass functions for x and y. So in this table, if you add all the columns, you would get the marginal mass functions for x, and if you add all the rows, so if you add all the elements in a given row and write on the margin, that's how the name margin comes actually, you get the marginal mass function for y. So let's do that. This on the left, we obtain the probability mass function, which is basically just the discrete probabilities of x. So and just make sure that they add up to 1. If you like, you can also find the mean value of x, the expected value, which in this case is 2.3. We could do the same thing for y and obtain the marginal mass functions for the random variable y. We could go one step further and try to just implement the conditional mass functions that we just looked at. So let us say we fix the value of y at 1. So if you would like to look at the grid on that three-dimensional figure, we are looking at the line where y is 1, and we are looking at all the possibilities of x only along that line. So now we need to normalize. That's how the conditional mass function of x given y is 1 would become a legitimate mass function. So what you see in the table on the top right corner is the conditional mass function of x given that particular value of y. And if you look at the table, which we can easily guess from the grid also, is that there is no mass for x equals 4 or 5, because that's what the problem states. So given y equals 1, the entire mass is concentrated for 1, 2, and 3. And after normalization, those three numbers must add up to 1, as they do. We could also find out the conditional mean, the conditional expectation, which we are going to define formally in a few slides from now. But it's easy to do that. Just multiply the value of x with its conditional probability. So 1 times 0.833 plus 2 times 0.133 and so on. So that conditional mean of x given y is 1 is 1.2. We can compare that with the unconditional mean of 2.3.